Hello everyone, welcome to Wi-Fi Learn. In this video, we can see about independent and dependent sources. There are several voltage sources as well as a current source encountered in our daily life, like batteries, DC generators or alternators, all very common examples of the voltage source. There are also some current sources encountered in our daily life, such as photoelectric cells and metadiene generator, etc. So, sources are normally classified as independent and dependent sources. Sources are normally classified as independent and dependent sources. In an independent source or the output of the independent source does not depend upon the voltage or current of any other part of the network. When the terminal voltage of the voltage source is not affected by the current or voltage of any other part of the network, then that source is said to be as an independent voltage source. This type of source may be referred as a constant source or a time variant source. Constant source is a source which is not varying to time. When a terminal voltage of an independent source remains constant throughout its operation, it is referred as a time invariant. For example, DC source is a time invariant constant independent source. Again, if an independent voltage source can be a time variant type, when then output terminal voltage of a source is a time varying type, where the output terminal voltage of a source changes with time. Here this terminal voltage of a source does not vary with changes of voltage of current that occurs in any other part of the network. It is varied with time alone. For example, it is AC voltage source and it is DC voltage source. Both are independent. They are not affected by any other voltage or current that occur in the electrical circuit. Similarly, independent current source. Independent current source is also similar to that of the independent voltage source only. Similarly, output current of the independent current source does not depend upon the voltage or current of any other part of the electrical network. It is categorized as independent, time invariant or time variant current source. The symbolic representation of the independent voltage source and current source with time variant and time invariant are shown here. It is an independent voltage source time invariant. It is an independent voltage source time variant. It is an independent current source time invariant. It is an independent current source time variant. It is independent current source time invariant. It is independent current source time variant. Okay. Independent sources are altogether independent sources are the sources in which their voltage or current is not affected by some other part of the voltage or current in the electrical circuit. That's it. Okay. But it can be time variant or time invariant. Okay. Now we can move on to dependent sources. Dependent voltage and current source. Dependent voltage and current source is a sources where the output voltage or output current is a function of voltage or current of any other part of the electrical circuit. Okay. This output voltage or output current can be a function of voltage or current that occur in any other part of the electrical circuit. Example is amplifier is an ideal example of the dependent voltage source. What is amplifier is the ideal example of dependent sources, where the output signal depends upon the signal that is given to the input circuit of the amplifier. Right? In an amplifier, the output of the amplifier is dependent on the input that is given to that amplifier. So, classifications of dependent voltage sources and current sources. Classifications of dependent voltage sources and current sources are voltage dependent voltage source, voltage dependent voltage source, or it can be also termed as voltage controlled voltage source. Voltage controlled voltage source. Current dependent voltage source or current controlled voltage source. Okay. And the third type is voltage dependent current source or voltage controlled current source, current dependent current source or current controlled current source. Dependent sources can also be time variant or time invariant. Dependent sources can also be time variant or time invariant. This is a symbolic representation of voltage controlled voltage source, that is voltage dependent voltage source, where this Vi is a quantity is defined somewhere else in the circuit. This Vi defined as somewhere else in the circuit, including the proper polarity and direction. Okay, including the proper polarity and direction. And this is a symbolic representation of current controlled current source. Current dependent current source. This is voltage controlled voltage source. This I1 and Vi or II or Vi or the quantities that is defined somewhere else in the electrical circuit, including the proper polarity and direction. Note the dependency factors A and beta. This dependency factor A and beta are dimensionless or unitless. See, from this equation A can be given as Vd divided by Vi, where Vd is also voltage, Vi is also voltage, that volt and volt will cancel, this is unitless. Similarly, here beta is equal to Id divided by I, it is also an ampere, unit as ampere, it also has a unit of ampere, this ampere and ampere get cancelled, it is unitless. So, in the voltage control voltage source and the current control voltage source, the dependency factors A and B or A and beta are dimensionless quantities. It is not necessary that voltage source be dependent on any other voltage and current source must be dependent on any other current. It is not necessary. Okay. And next type, it is current controlled voltage source. Current controlled voltage source, and here it is voltage controlled current source. Here this current is controlling this voltage, and here this voltage is controlling this current. So it is termed as voltage controlled current source and this current controlled voltage source. So controlling this current I1 and controlled voltage V1 must be somewhere defined in somewhere else in the circuit. This I1 and V1 are defined somewhere else in the circuit. Here in this case, this dependency factors will have units. This rho is equal to Vd divided by II, Vd divided by II, which has a unit of ohms, or rho. This does not mean that this rho represents a resistor. It is simply the factor that relates a controlled voltage and a controlled current. Depending voltage and the controlled current. Okay. Similarly, gamma is equal to Id divided by Vi, which has a unit of ohm inverse, Zemin. Once the dependent sources are located in a circuit with the definitions for the controlling current and voltages, then the circuit analysis must be proceed as always, like KCL, KVL still apply, and all the techniques derived from these also still apply in the dependent voltage source. In a particular voltage divider, node voltage method and loop current techniques are all unchanged, but this dependent voltage source method is related in all these methods. We still apply this dependent voltages in all KVL, KCL, loop analysis, voltage source, node voltage divider, node voltage method, loop current method. All these techniques are not unchanged. Since a dependent source is defined in terms of particular voltage and current, you must be careful about changing the definitions or changing the directions. Overall circuit behavior must remain unchanged. Sources, normally in dependent sources, it is defined in terms of particular voltage or current. So you cannot make more changes in directions as well as the polarities. The overall circuit must not change the behavior. Okay. I hope you understood the concept of the dependent sources and independent sources. If you have any doubt, please leave it in the comment section. And if you all like the video, you all know the drill. Like, share and subscribe to Wi-Fi Learn. Thanks for watching the video.